Hi everyone, welcome back. Okay, so we are moving on to lesson 2 in module 3, topic 3. So module 3 says module 3, topic 3, lesson 2. Okay, so the review, we have the power of the intersection using graphs to solve problems. Learning goals, analyze the relationship between the independent and dependent variables in a graph and relate the variables to an equation. We've already been doing that. Use graphs to solve one-step real-world problems. That'll be nice to use a graph and apply the one-step equations, which we've done just previously. Use an inequality in the form of x is greater than c or x is less than c to represent constraints or limits when solving a real-world problem. The review first says to determine which equations represent proportional relationships and explain how you know. I have this other writing I put here. So the question comes up then, what's a proportional relationship? So to know if a relationship is proportional, you have to look at the ratios between the two variables. If the ratio is always the same, then it's proportional. Remember, way back at the very beginning of the year, we talked about ratios and their different forms, like 2 to 3, to the word 2, 3, or to the fraction bar 3, still read 2 to 3. If we used variables for it, a to b, a to b, or a to b. So if we can get this in one of these forms, then we can know if we have a proportional relationship or not. So I notice that we have a coefficient with our variable. So if I divide both sides by n, not 2.5, if I divide them both by n, then I'll have c over n equals 2.5, because that cancels out. So this one is proportional because no matter what my c or n is, c over n, c to n is always going to be 2.5. So yes, this one is proportional. 2, L equals W plus 25. So this is connected with addition. Here we had a connection with multiplication, so we could divide to get it in this ratio form. I can't do that here. It is not proportional. It doesn't matter if W is 2, L is going to be 27. If W is 5, L is going to be 30. This one, it changes. It's not proportional. So, and it's because it is an additive relationship. Here, number 3, we have 1/3 T equals our D. D equals 1/3 T. So again, we have a multiplication. We can get the 1/3 by itself. We can divide both sides by T. So we would have D divided by T, or D to T is 1/3. So this one as well, proportional. And then this one is very similar to number 2. Even though it has a subtraction sign, we still say it's not proportional because of an additive relationship. Okay, again, if you need to pause and get things written down, please do so. And I'm going to move on. So next, we are up to page 490, the getting started. Nick sells pretzels for $1.25 each at the morning events held at the community center. At the end of the events, he's supposed to report the number of pretzels he sold and the total amount of money collected. Nick sold pretzels on 3 different mornings, but he only reported either the number of pretzels sold or the dollar amount collected. Calculate each missing piece of information from his daily reports. Okay, it says ask yourself, are the independent and dependent, what are the independent and dependent quantities in this situation? So let's see. The dependent and independent, what would change based on the other? Does the number of pretzels sold affect the amount collected? Or does the amount collected affect the pretzels sold? Yeah, so this is going to be our independent, and this is our dependent. Remember, our independent is always on the X, and our dependent is always on the Y. So we're going to say for number 2, actually we need to fill out here number 1 yet, the rest of the information. So on Friday, if he sold 15 pretzels, I'm sorry, 16 pretzels, and they're $1.25 each, then the amount collected here is going to be 16 times that $1.25, which gives you $20. On Saturday, we would have 40 times the $1.25, which means he would have $50. Okay, so what if he has $40? So how am I going to work it backwards then? I'm going to use division. So let me show you how to do this. So let's use the 16 because those two 40s will kind of be confusing. So if we had 16 times $1.25 equals $20. But now we have the 40 and we still know $1.25, and we're trying to figure out this number right here. Okay. Remember when I said you can use math equations that you can get the right answer? So let's say we had 4 times 3 equals 12. We could work backwards by saying 12 divided by 3 equals 4. So 12 divided by 3 equals 4. So in this case, we would do 20 divided by $1.25, it would equal 16. Or here, we're going to do 40 divided by $1.25. And what will that give us? So 40, if you have a calculator, do that. Because $40 is between the 20 and 50, my answer should be somewhere between 16 and 40. I expect it to be closer to 40 because this $40 is closer to the 50. So 40 divided by $1.25 on your calculator gives you 32. So he sold 32 pretzels on Sunday. Number 2 says define the quantities and write an equation to represent the relationship between the number of pretzels sold and the amount of money collected in dollars. So let X equal the number of pretzels sold and let Y equal the amount of money collected. Okay, so that's the first part, define the quantities. Notice it says and write an equation to represent the relationship. So our Y, our amount collected, we determine from taking the number of pretzels and we multiplied it by $1.25. So we would have the amount collected was the Y, the number of pretzels was the X times $1.25. But remember, our preferred algebraic method of representing that would be Y equals, instead of doing X times 125, we would be doing $1.25 X. It means the same thing. This is $1.25 times X. This is the preferred way to write it. Does this situation represent a proportional amount? Just letting you think about it. So yes, it does. I want you to write all of this, please. This situation represents a unit rate of $1.25 collected for every pretzel sold. Okay, again, if you need to pause, please do so and make sure you get this all written down. That's an E. It's a terrible E, but it is an E. Activity 1. Using a graph to determine unknown quantities. I said in getting started, you used an equation to represent the relationship between the number of pretzels Nick sold at the community center and the amount of money he collected. You can also use a graph to represent this relationship. The graph shows the ordered pairs corresponding to the amounts you determined in question 1 in the getting started. And the corresponding equation is y equals $1.25 times x. It says label the 3 ordered pairs shown on the graph. So we can do that. So to label the ordered pairs, the x goes first and then the y. So if we go over, this is our x-axis. So if we go over to our x, it looks like this is going up by 2, 4, 6, 8, 10, going up by 2. So 10, 12, 14, 16. So we have over 16, and then it went up to 20. So this one is 1620. This one is 3240. And then we have over to 40 and up to 50. So this is 40, 50. What does each ordered pair represent? Well, the X is the number of pretzels, and the Y is the amount of money collected. Last one says, identify the unit rate in this situation. Well, remember, a unit rate is a per one rate. Per one. A per. Remember, the line means one, or per one. So it was $1.25 per one pretzel. Our unit rate was $1.25 for one pretzel. So one pretzel, number of pretzels is the X, was $1.25. That should be on the graph. So if we're going up by twos, then $1 is going to be right here. So our $1.25 is going to be right there. So plot and label that, please. Take note, one way to analyze the relationship between ordered pairs displayed on a graph is to draw a line, like they did here. Notice it has an arrow because it would continue on. In some problem situations, when you draw a line, all the points will make sense. In other problem situations, like this one, not all the points on the line will make sense. So what points don't make sense? Would you sell half of a pretzel? No, you're not going to sell half of a pretzel. So like if here's 12, so here's 11. So if I just came over in between the 10 and the 11, This point right here on the graph isn't going to make sense. You're not going to purchase half of a pretzel or a quarter of a pretzel. Okay, moving on. Again, you pause as you need to. You can use a graph to determine an independent quantity given a dependent quantity. So you can use the graph to determine how many pretzels Nick sold if he collected $10. Remember, the solution to an equation is any value that makes the equation true. The graph of an equation is the set of all its solutions plotted on a coordinate plane. So the graph of an equation shows all of the solutions that would work. It says first locate 10 on the y-axis and draw a horizontal line. So that's what they did here. This shows that $10 is the amount of money being collected. The x value of the point where your horizontal line intersects with the graph of $1.25x is the number of pretzels sold. So basically, where this $10 hits the line that we drew on the previous page, that's the number of pretzels. So if we follow it down, it's going to take us to, that's right, 8 pretzels. Remember, if you have questions about this along the way, please make sure you send me a question in the chat on Teams. Make sure you pause along the way. It was 8 pretzels. Sorry if that wasn't in the picture a second ago. Use the graph and the worked example to answer each question. How many pretzels did Nick sell when he collected $25? So we're going to find $25. This is the money. So 20, 22, 24, 26. So 25 is halfway in between here. 22, 24, 25. Hits the line about right here. And as we bring that down, it's kind of hard for me to see. Let's see here. Where did my straight edge go? No, we're just going to try it. 22, 24, 26. So let's say 25. Is that what it said? $25. And my graph is showing it here. Okay, so I paused the video here for a little bit because I was a little bit confused as I was coming across here. I know that the answer should be 20. I know that $25 would be earned if it was 20 pretzels. $1.25 times 20 pretzels. I don't know if I've showed you guys this. Offset the 0. 2 times 5 is 10. 2 times 2 is 4 plus 1 is 5. 2 times 1 is 2. 2 places for the decimal. So I know it's 20 pretzels, but it didn't seem to line up. Then I realized, and you have to be careful. See, and I told you guys all the time, even I make mistakes, and I'm not going to stress out about it because it's just what happens. We're going across by 2's here, but we're not here. Between 0 and 10, there's 1, 2, 3, 4 lines. So this is going up by 2 50s. So 250, 5, 750, 10. 1250, 15, 7, 15, 20. 2250. So right here's 25. And it makes sense. It's halfway between the 20 and the 30. So if I'm following it across right here, now I'm directly hitting the 20 line. That makes a lot more sense. Okay, so that first question then is 20 pretzels. $33.75. So where do we have 33.75? So we have 35 here. So we have 32.50 here. So 33.75 is going to be in the middle here. And it's going to end up being in the middle here. 22, 24, 26, 28. So this is going to be 27 pretzels. And again, you can check it with the math using the equation y equals $1.25 times x. We can do 33.75 equals 1.25x. Divide both sides by the $1.25. Divide by the $1.25. That cancels out. We have x equals, in your calculator, if you did 33 divided by $1.25, you will in fact get 27. Okay, C, $40. Well, that one should be pretty easy. We're going to go straight across. $40 crosses it right here, which I will then follow down. And it looks like we're at 32 pretzels. Does everybody see that? Okay, so now it says more than $45. Oh, sounds like an inequality, doesn't it? Greater than 45. So how many pretzels does he have to sell to get more than $45? So 45 is going to be this line right here. So pause it and see if you can figure it out. Okay, so the 45 comes across to here, which then ends up being here, which is where 30, 32, 34, 36, 38, 40. So this is the 36. So if it says more than $45, we're not talking about it equals $45. We need more than $45. So if we sold 36 pretzels, we're getting exactly $45. So it can't be 36 pretzels. It has to be more than 36 pretzels. Now it says at least $50. So at least $50. So our $50, use this highlighter this time. The $50 comes across to here, and then if we followed that down, we're at 40. So $50 or more is what at least means, correct? At least 50. So that means $50 or more. So here's the $50 and it's 40 pretzels. So it would be 40 pretzels or more. Or we could say greater than 40 pretzels. Greater than or equal to. 40 pretzels or more is the equal to. More than 36 would be just greater than 36. Nick reported that on a Saturday morning he sold 13 pretzels and collected $16.25. And on Saturday afternoon he sold 42 pretzels and collected $47.50. Do you think he reported accurately? Well, let's see. So 13 pretzels is $16.25, he's saying. So 12, 14. So 13 pretzels would be here. And he's saying that this is how much? $16.25. Okay, well, this is 15, so that's based on the way the graph is looking. I would agree with that. And on Saturday afternoon, he sold 42 pretzels and collected 47.50. So 42 pretzels will be here. Now, wait a minute. On this one, let's see. 47.50. If at least $50 was 40 pretzels, can 42 pretzels be 47.50? We need 40 or more pretzels to get $50. So can 42 pretzels get us 47.50? 42 would be here. That's going to be all the way up here at the top. That's going to be 52.50. So he is not correct. Nick did not report correctly. So 42 pretzels on the graph does not match with $47.50. All right, make sure you have all of that written down. And based on this reasoning, we could say if 40 pretzels or more is needed or needed for at least $50, then 42 pretzels cannot earn less than $50. And there you go. Go ahead and pause so that you can get that written. And I'm going to stop there with activity 1.